Hello guys, I'm back. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. And today I am here to share with you my answer to the following question that I received on my LinkedIn profile. Do you know why we shield the gas and reduce its temperature before going to the TEG dehydration unit? In my case, we reduce its temperature from 50 to 20, then we did the dehydration with TEG. Thanks for your time. So the first thing my first observation here is that every time that we deal with chemical process engineering and plant design, it's important to clarify what is the units of measurement considered in your project. I live in Brazil and I deal with different projects around the world, or I deal with projects with interface different people around the world. So it's important to know if I am talking about temperature in Celsius, Fahrenheit, Kelvin, Rankine. Of course, that depending on the value, I can consider or I can assume some considerations. Here, I assume that we are talking about Celsius degree, because eventually if the gas is compressed, it will increase its temperature, and 50 Celsius degree it's reasonable, and because of that the process wants to reduce the temperature for 20 Celsius degree. If we are talking about Fahrenheit, it will be below 0 Celsius degrees, so you would freeze the water available in your gas. But in any case, every time that you deal with chemical process engineering and plant design, let clear what is the units of measurement. That said, the TEG process, the TEG dehydration process, is a process to remove the water from a gas. It's most common, or it's very common, in the natural gas processing, where we need to remove the water from the natural gas to prevent, for instance, the formation of hydrates. So based on that, we have a column, and at the top of the column, we have the feed of TEG, 3-ethylene glycol, and the TEG in contact with the gas in countercurrent will absorb the water available in the gas, and in the bottom of the absorber column we will have a TEG solution, rich TEG. It means that the TEG is rich with humidity or water, and this TEG will go to a regeneration cycle. And in the top of the TEG we'll have a natural gas stream without or with much less water than it could be. It will not be saturated with water. It will be dried in a value depending on the flow rate and the characteristics of the project. So when the question is, if I will remove the water from the natural gas, I am assuming that it is natural gas, but can be other gases also. If I will remove the water from the natural gas with TEG, why I need to cool down the natural gas? Each project has its specifics, so here I giving to you general comments. Of course, that for the correct evaluation, for a specific evaluation, we need to have all the information related to the specific project. But let's here do some considerations. Let's assume that the gas at 50 Celsius degree is saturated with water. When I reduce the temperature of a gas at a constant pressure, it means that the water that is saturated at 50 Celsius degree will condensate, because I am reducing the temperature, but I am keeping the same pressure. So when I reduce the temperature, and the condensate will form, and before getting in touch with the TEG, before entering the column, or if we are talking a column that at the bottom has a vessel separator, I will be able to remove the excess of water before sending it to my process. And that is beneficial for two main reasons here. Of course, there are many other reasons that can be added, but I will focus on two reasons to do that. The first thing is that the column size is based on the vapor flow. There are relationships and correlations for the pressure drop in the column and in the velocity of the column. And if I reduce the water that is at saturated conditions, so it is in gas phase condition in my gas, I am reducing the flow of fluid that is going in as gas to my column. And with that, I can, just for this reason, I can reduce eventually the size of my column in terms of diameter. The other thing is that as I have less humidity, I have less water in my gas, I will need less TEG recirculation rate to remove the amount of water that I need to have to reach the specifications of some gas pipelines. So when I reduce the amount of TEG that is needed to be recirculated, it means that I have less TEG recirculation. I have a less flow in my pump that is recirculating. If I have a less TEG recirculation in my pump, it means that I can have a pump, smaller pump than if I don't remove the water previously. And with a smaller pump, I will have a lower capex. The pump most often will be cheaper than a bigger one, and I will also has less OPEX because as I am recirculating less flow, I will use less electricity, for instance, to add the energy needed to pump this TEG again to the process. So this is at least two reasons that you will do the cool down of the gas before entering your absorber column for dehydration. So guys, this is it. I hope you like it, and I'll see you soon in the next video. Bye bye.